Okay guys, trig functions of general angles. So now we're going to have angles that are not an acute angle. So our first one, it says a point on the terminal side of an angle theta in standard position is 3, -6. Find the exact value of each of the 6 trigonometric functions. I think I cut this one off because I had to was trying to save space and get this problem on, but y'all understand what's happening. I wrote the other ones down here at the bottom. So draw your point, 3, -6, then draw a triangle. So we have 3, we have -6. This is the only side that's going to stay negative. The hypotenuse is never negative. We use Pythagorean theorem to calculate the hypotenuse. So we have 3 squared plus -6 squared. If you put this in your calculator, you must put parentheses around the negative or you are not going to get the right answer. So if you would rather just look at this as 3 squared plus 6 squared, do it. So this c squared equals the square root of 45. We can actually reduce this and you will get marked wrong if you do not reduce the square root of 45. 45 is 9 times 5. 9 you can take the square root of, so it's 3 square root of 5. Now we just fill in all of our trig functions, but we're careful about our negative sign. So our sign is still opposite over hypotenuse. -6 over 3 square root of 5. Notice it simplifies. 2 over the square root of 5. Negative, sorry. They have rationalized their denominator here, but if you put it in like this, you will not get marked wrong. So either answer is fine. Cosine, so we're going to do cosine. It's going to be 3 over 3 square root of 5. It simplifies. Tangent is -6 over 3 or -2, and you just keep going, but watch for your negative signs. Now the next one, it says the cosine of theta is -12 over 13 in quadrant 2. We draw it in quadrant 2. We use 12, 13. We're going to use our Pythagorean theorem to find the other side. Our other side is 5. It's actually a Pythagorean triple, but if you did 12 squared plus b squared equals c squared, you're gonna get 5. Then fill in all your trig functions. Just be careful that cosine and tangent will be negative, remember? So cosine is negative, tangent is negative, cotangent is negative, and secant is negative, okay? Sine, because it follows the y-axis, is still positive in quadrant 2. Okay, next one. Use the reference angle. So the reference angle, remember, smallest angle to the x-axis to find the exact value. So it says 25 pi over 6. You can convert this to degrees if you want. I just counted by pi's over 6. If this is pi, this is also 6 pi over 6, 12 pi over 6, 18 pi over 6, 24 pi over 6. I have 1 pi over 6, so my reference angle is pi over 6 or 30 degrees. So we know our 30-degree triangle. It's the tangent. It's opposite over the adjacent, 1 over the square root of 3. Now we have cosine of 600 degrees. 600, if you figure out where your reference angle is, this part goes with this problem. You're down here in quadrant 3. So you get 360. If you add 180, you are at what, 540? So then you have 60 more degrees. The reference angle is 60. So it's negative square root of 3, -1, and 2. So we have for our cosine, it's adjacent over hypotenuse, -1 over 2. This last one, it says use the coterminal angle. The coterminal angle turns out to be the reference angle here too, but coterminal means you're going to subtract or add 360 degrees until you get between 0 and 360 degrees. So if I subtract 360 here, I get 60 degrees. We know what the cotangent of 60 degrees is. I've drawn it here. It is 1 over the square root of 3. Okay, next video is the last one, guys, for test 1.